Hey everyone, I'm excited to talk to you about auto instrumentation with the OpenTelemetry collector today. My name is Ansh Chaudhary. I'm a product manager at Splunk, and I'm focused on helping customers get their data in to the Splunk Observability Cloud Suite. So, how many of you have heard of OpenTelemetry? For those who haven't, OpenTelemetry is the second most active project in CNCF today after Kubernetes. It is an open source project that helps provide instrumentation to capture telemetry from your environments. It does support a number of different open source and proprietary backend solutions that you can export this telemetry collected to as well. Splunk is one of the top contributors to this project, and the Observability Cloud Suite is OpenTelemetry native. We'd love for you to be involved and ask us if you have any questions. There's incredible momentum for this project, with major cloud providers like AWS, Azure, and GCP contributing, as well as a number of observability solutions. End users themselves are involved with these efforts and have been additionally giving some great feedback. So, what are few of the challenges faced with adoption by the end? Then you can simply start off the app to get started. For manual instrumentation, on the other hand, you do need to make code level changes to the app, which makes it slightly harder than automatic instrumentation because you do now need to edit your code. You can capture then and really send this telemetry directly from the application or send it through the OpenTelemetry collector deployed as an agent and then possibly as a service to different backends. In the case of auto instrumentation, some of the challenges involved are related to management and deployment. It is difficult with a single instrumentation library required per language. Second, there is configuration required as well, where you change runtime parameters or options for each runtime running in your environment that needs to be instrumented. For us, one of our goals is to simplify and shorten that time that it takes you to see the full value of OpenTelemetry and observability, which will then help a lot with adoption within your environments. Now, to solve these problems, you won't even need to install and configure different language specific auto instrumentation agents. Instead, the collector with the deployment itself will include those instrumentation agents and will then automatically instrument all those runtimes that it detects. So now you simply need to deploy the collector and start your application to be able to instrument them. Let's now jump into a demo. So let's wrap up with some takeaways. First, there's no or zero configuration and deployment of runtime specific auto instrumentation needed anymore. Second, this is completely optional. You can choose to opt in with a deployment option for auto instrumentation with the collector itself. Third, for applications that are instrumented, the service name is automatically generated and set, and it can be overridden as well. And lastly, while I walked you through the steps for a VM in the demo, auto instrumentation with the collector deployment for Kubernetes is actually supported already with the OpenTelemetry operator. This operator can be used to auto instrument Java, Python, Node, and .NET runtimes. So that's it. Hope you found this presentation and demo interesting. Feel free to try this out and give us feedback. Thank you.